So on these bottom two problems, instead of going from standard form to vertex form, here we are just given a couple of key features about the parabola. So it says write a quadratic equation in vertex form for each parabola described. So I'm going to go ahead and just write that skeletal structure of vertex form. Y equals a times x minus h squared plus k. So this is what we want to try to write. And we want to figure out what it is we know about each of these parabolas. We know that the vertex is at 3, 2. That's going to help me figure out my h and my k value. But then I'm just given some other random point on the quadratic. What can I use that point for? That point is just going to be some x and y that works in the equation. So if I want to write this equation, what things do I need to find? I need the a value, the h value, and the k value. We have h and k. We have an x and y, which I don't need to write the actual equation in vertex form, but what I don't have is the a value. So we need to find our a value. So need to find the a value. So we're going to start by plugging in what it is we already know in this equation. We are going to use -2 for the y value. So -2. Actually, I'm going to go ahead and rewrite the skeletal version down here. So y equals a times x minus h squared plus k. We are going to plug -2 in for the y value. Now, what are we going to plug in for the a value? Nothing. We don't know what the a value is, so we're going to leave it as a variable, and we're going to try to find it using these known values. So it's kind of like back in Algebra 1 where you knew maybe the y-intercept of a line, but maybe not the slope, or you knew 2 points, but you didn't know the slope. So we're going to be using some known key features to find hidden key features. So for the x value, we're going to plug in -1. Now, if the vertex is at 3, 2, what is that 3 going to look like in the equation? -3. It always switches signs from the coordinate to the equation. And then our k value, what's that going to be? +2. So folks, we want to write it in vertex form. We want to find our a, h, and k. We were able to figure out our h and k, but we need to find the a value. So we're going to use this other SCSI point on the quadratic and solve this for our a value. I want you to put a note by this that says, PEMDAS. Good old PEMDAS, back to haunt us. From a PEMDAS standpoint, where should we start in the simplifying process? Inside the parentheses. So -2 equals a. -1 minus 3 is -4 squared plus 2. What would PEMDAS say we should do next? The exponent, so -4 squared. What's -4 times -4? We're not even going to use our calculator. +16. So we have a times 16 plus 2. And it's a little awkward having that 16 times a, so we're going to write it as 16a plus 2. So from a solving standpoint, I want to figure out what a is equal to. We want to somehow isolate it. Who should we move first? Minus the 2, so swing that 2 over here. and we get negative 4 equals 16a. Now, before you say a is negative 4, how do we isolate the a? How do we get rid of that 16? We got to divide by 16. So, negative 4 divided by 16 is a negative 1/4. You can use your calculator to check. Remember that key sequence to simplify fractions. After you type it in, negative 4 divided by 16 is math, enter, enter. Negative 1/4. Let's go ahead and write that down. Math, enter, enter. The worst thing that happens with these problems is students stop here and they go, a is negative 1/4, we're done. We found the a value, but did we answer the question that says, write this equation in vertex form? No, we did not. So we need to now take that a value and plug it in with the h and the k value into this skeletal form. Let me zoom out a bit here. So now that I've got a, I want to use this and the vertex to write that equation in vertex form. So y equals, my a value is negative 1/4. And then x minus 3 squared plus 2. So what do we know about this graph from this equation? We know that it has a vertex at 3, 2. 1, 2, 3, 1, 2. We know that negative 1, negative 2 is another just rando point on the graph. So if I need to go from my vertex to this other point, not my best quadratic, it looks like a sand graph. Is this consistent with what we found our a value to be? Yep, negative a value means it should be sand. So sad graph, negative a value. We can also check this equation on our calculator. So if I type this in, y equals negative 1/4 x minus 3 squared plus 2. Big one. So we can verify that it looks with what we guessed with our sketch, but also we can check these 2 points using our trace button. When you hit trace, it engages your x equals y equals, and if I type in that value of 3, what should I get for the output? 2. Boom, there's my vertex. If I type in negative 1, what should we get for our output? Negative 2. There's that other point on the graph. So folks, best news is you can use your calculator to check yourselves on these, but you do need to show this appropriate work of how you found that a value. Questions so far? Pretty dry stuff, but the nice thing is it does have some review of that transformation rules that we learned earlier in the unit. So folks, let's go ahead and jump right into problem B. We've got our vertex, negative 1, negative 2. That's going to tell us our h and our k. H for horizontal shift, k for, I don't know, they use that for the vertical shifts. Now this point is just some x, y value on the graph. Now folks, let's just go ahead and sketch out what this would look like given those values. Doesn't have to be exact. Let's just get a rough idea of what this would look like. Negative 1, negative 2 is my vertex. V for vertex. And then negative 4, positive 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So way up here. So if this is my vertex, I'm going to have to curve up to connect to that point. So what do I know about the a value that I'm going to need to find? Is it going to be a positive or a negative? It's going to be a positive A value. It's a happy graph. So our A value should be positive. And this is a good thing to keep in mind when you start solving because it's really easy to miss those negatives. So folks, this is similar to what we did back with polynomials with end behavior and finding the leading coefficient and plugging in known values like the x-intercepts to solve. So folks, let's go ahead and start with this one. I'm going to start by writing vertex form. Y equals A times x minus h squared plus k. We're going to fill in what we know. What are we going to use for the y value? That point that we have, 13. The a value is what we are looking for, 8. Then, what will we put in for the x? The -4. And here's the tricky part. What are we going to put for the next number? Positive 1. Excellent. It's -1 in the coordinate, so it needs to be a positive 1 in the equation. And that only is for the h value, those inside transformations that are opposite signs. Squared. And then plus our k value. Our k value is -2. So we just write -2. And now it's PEMDAS time to try to solve for our a value. So we start inside the parentheses first. -4 plus 1 is -3. Sometimes students will forget that power of 2, both with writing the skeletal form and when they start simplifying. So 13 equals, what's -3 squared? Handling the exponent next. 9. So then I'm going to go ahead and take a times 9, multiplication next, 9a minus 2. To isolate the a, we're going to first need to add that 2 over to the other side. So 15, 9a, divide by 9. And are we going to leave my a value as 15/9? What can we divide out of the top and the bottom? A 3. 15 divided by 3 is 5, and 9 divided by 3 is 3. So A is 5/3. And again, if you wanted to use your calculator, you would do 15. Let's get out of our graph. 15 divided by 9. Math, enter, enter. Boom. Simplifies it to be 5/3. So now we have our A value. So we're going to use that and our vertex, which is -1, -2, to write my vertex form equation. So y equals 5/3, there's the a value, times x plus 1 squared minus 2. And there's our equation in vertex form. So now, if I wanted to check myself, I can type 5 divided by 3 for the a value, x plus 1 squared minus 2, and I can verify both of those points. If I type, I have to hit trace, and type -1, and we see -2, and that does indeed look like my vertex. If I type -4, it tells me that y value is 13. So if I got something like 18, that would mean that the equation I put in isn't a match for these two key features. So you can use your equation to check yourself. Any questions on those ones? All right, we're going to go into the blue guided practice next. We're going to start putting this all together.